Okay, Noel's here. Raise your hand if my voice clear. One student haven't joined us yet. Who is the one student here? Celine here. Can you look for me? Who else absent? So Wong Yap Hao here, Wong Zi Sang. I'm not sure whether they are physically here or not because didn't raise hand. Jeremiah. Am I right? Jeremiah not in yet. But anyway, we have to start our. Jeremiah here. 13, 14. We shall have a 15. Then who is missing here? We suppose have 15, right? So one student missing. Who is the missing student? Can you look for me? Or Lim. Lim not in. Okay. Let's see how. If later not join, then we'll be absent. Today, we have to complete this chapter. About 40 plus slides. So I will go a bit speed up a little bit. I will cover whole chapter and then during a tutorial class, we will discuss in more detail the component required in your quality plan assignment. This is our week 4 already. Are you ready? You might bring your pen or paper in case you need to jot down any point. So we look at the software metric and measurement. This is our content today. What is a software metric? The purposes, types of measurements. So this one, definitely you all need to determine what is the best measurement metrics used in your system. But before decide metric, you need to determine which attribute you want to assess first. Okay, here, concern with deriving numeric value. So here is a keyword. Quantitative evaluations and attributes in your software products. So this one, software measurement is concerned about. We want to, keyword stated here, quantifying. We want to measure, we want to quantify some of the attributes of our software system. Such as example, we want to measure complexity or the reliability. Here we're talking about the process. We don't look for the final deliverables or the product, because if we measure after the whole project completed, if any amendment or changes required, that might cost a lot of money. So by comparing the measure value to each other, by comparing the value, the outcome from our evaluation, we're able to draw some conclusion about the quality of our software system. Right, so in long term, this software measurement is used to make a judgment on the software quality. It can be used to access, plenty of a metric can be used to access the attribute. They are no specifically stated the best metric for particular attribute. Yes, I repeat, there are plenty of measurement metrics available used to assess the range of quality attributes, but they have no specific best match metric to particular attributes. It truly depends on the environment of your software system. And the attribute here sometimes will not solely stand alone, because attribute like let's say availability, will it be also related to security? Some are depends, the attributes depends from one and another. So different cases, different software development, different organization, different environment. So that's why there are no specific best match metric for particular attributes. Okay. So we look at next one. Assign value identify system component. Now, the reason of measuring this software process, first, we want to understand. We want to establish the baseline for the future comparison. That's the first thing. Second, we need to know, we need to evaluate the current status of our software planning. Followed by, we need the result to estimate the final outcome. We need to understand the process to determine if that everything goes right, no problem, then big probability the final deliverables will not have any problem. Hang on, have I started recording? Yeah, not yet, not yet. Nobody remember this. Halfway already. Okay, the next reason for measuring software processes is used to improve. When we have more information, when we have more quantitative information, it's helped to improve for the coming level, coming processes. Okay, software metrics here. 4.2. Use of a software metrics. Types available. So quantitative measures of degree to which a system component given attributes. So these are the common metrics, but in the real world, there are plenty more other metrics available. Yeah, here, common use, but there are still other metrics. So means when you are looking for the metrics in your quality plan, students need to do a lot of literature review to find which metric is the best match. This one I will following slide, I think slide 20 plus, and after we'll go through this one by one. So let me proceed first. So we look at here, quality control, project control. So the use of a software metrics is for quality control, project control, productivity assessment, and estimations. So this is a purpose. So quality control here used to measure the performance against the quality standards in documentation, determine whether the current status can meet our expectation. Yeah, project control, of course, we would like to keep track the overall project performance. So number 4, productivity assessment, and 4, estimation. So next one, match the following examples of metrics to the purpose of measurement. Or yours one, this one, bring your line here. Let me use my, so quality control, most of the time we use quality control, we use, okay, error per 1,000 lines of codes. Quality control also, we might assess the defect per thousands lines of code. So this one. After that, the other one will be also another error here. Okay, the purpose of the measurement, there are 4, and their relevant metrics. So we might use this formula or matrix we call. So how we read this, errors per 1,000 line of codes. No worry, this one later we will explain in detail. So we find out the defects, the errors. So for the project control, most of the time we will look at the cost. Okay, this one cost. And then also we look for pages of documentations. This one. Okay, the rest not. Productivity assessment, we will look for. Oops, let me clear first. Productivity, error per person, months. Productivity. Wrong place. Oops. Historical metric. Lack of one column. 1, 2, 3, 4, 5, 6. Still got one more. Later, I will add on for you. Okay, here suppose one more. Yeah? Here one more. How many metrics you have in your notes? Is it same with this? Historical metric is the historical metrics. Mean from the past, past experience as a guideline. Okay, historical metric 1, 2, 3, 4, 5, 6, 7. So estimation, this one, yeah, historical metrics. 4, 5, 6, 7. Project control, so we have 2 here. And then also one more, we can use person. Okay. So 3, 3, 1, 1. 3, 3, 1, 1. Have you jot down? Yeah, have you jot it down? If yes, raise your hand. So this slide shows relevant metrics with their purpose of measurement. Okay, everybody done, yeah? Okay, let me briefly explain this one. So for the first metric, yeah, error per thousands, this one stands for the K, L, or C. K here means kilo, yeah? K. But we will read as thousands of lines of codes. So K, L, or C. This is a classic metric. Yeah, this is a classic metric used to measure the size of a software by thousands of code lines. And this one, KLOC, often used to estimate the required time for a team to build a project. Number second, defect, KLOC. This is a referring to a defect density, numbers of defects. Number of defects in the software or module during specific period. So when we want to do our data set, we need to specify what is the time period, and then you record down numbers of defects, do some calculations. After that, LOC lines of code, pages, we have 2 exercises later on this. Then person month, also we have more explanation later on. Let's look at the next one. Indicator. Metrics or combinations of metrics that provide insight. So indicator means you give you some guideline, yeah? Insight into the software project, process, project or product itself to improvement or adjustment. So example, 800 errors, they exist. From the data set, we do measurement and results found that there are 800 errors per kilos of lines of codes. So this amount is an indicator to show that the software is a software with poor quality. But how to determine this poor quality here? Is it any, how do we know this value? Yeah, perhaps some of you might ask, how do you know this value under this category? Give me your answer in the chat box. Yeah, show me your opinion. How do we know that the 800 errors in the poor quality category? Yeah, early morning, I haven't wake up yet, your brain. Give me your answer in the chat box. How do we know? Yes, logically, yes. 1,800 error, definitely. So approaching. 800% error. Assuming one line, one error, then 80% poor. Yes, yes, yes. Best scenario is 0. So, yeah, based on our understanding, is about 80% error. So this is poor quality. So is there any range? Is there any range, like, is there any range, the scales, like 0 to 200, what category? Do we have this? This one we need student go to find out this. Yeah, do some research and find out what is the similar metrics measurement done by previous studies. Yeah, we take it as a reference. Again, there are no specifically appointed that must use this range. Do you know why? Because we have to look, now we only look at numbers of errors, but don't forget different software system has different complexity. Yeah, different complexity, and we don't know how many person involved and so on. There are so other attributes that might affect this. So that's why even though you found out, oh, your scale like this, but how come other people different scale? It depends on others attributes in their environment. Then how do we know yours correct or not? Then we have to look at what metrics that you are searching for and then how relevancy to your system. Okay, type of metrics we look at here: product, process, and project. So product metric, two classes, dynamic and static. So if you want to make it clear, you can do like this. Product metric, you have two, so you list it out here. So you have two, so you list out. Okay, one is dynamic, and then one is a static. So product metrics concern with the quality of the software itself. As the name, product metrics. So two classes or two category: dynamic, static. Dynamic metric used to, keyword is here. They will assess, this metric used to assess efficiency and reliability. Okay, efficiency and reliability. So this product metrics is a type of measures or measurements of a different characteristic of a software product. So the two important software characteristics here, including look at the size and the complexity of the software, as well the quality and the reliability of the software. So static metric collected by measurement made of the system, so help to access. Static mainly used to access complexity, understandability, and also maintainability. So we look at more explanation here. So when comparing dynamic metric and also static metric, dynamic metric easier to measure, relatively easier, yeah, compared to the static metric. So examples of a measurements. Okay, these two good example. Time required to start up the system. So here under attributes, performance, efficiency. The numbers of a system failure. So we can use dynamic metrics to measure reliability attributes on numbers of system failure. So again, comparing both static and dynamic, these dynamic metrics more easier to be used or easier to be measured. How about static metric? So look at the slides. Have an indirect relations with quality attribute. Indirect keyword. You need to try and derive. So mean we have to do this. Okay, we have to think of what's the relationship of the metric used to the attributes. This is a quality attributes. So when using this static metric, so these are examples of static metric. When using this, we have to derive a relationship. We have to develop, we have to know what's the relationship between the metrics and the attributes that we're going to measure. Okay, same, isn't it? Same slide. So next one. Cyclometric complexity. There are several detailed test metrics used to check the complexity of the code. One of it is used this one, cyclometric complexity, which this will count the amounts of amounts of linearly independent path through the program source codes. So you look at here, independent path, any path through the program that produce at least one new sets. Okay, you may look at the reference 3, page 446, more explanation there. So here talk about, like, let's say path 1 from here, from 111. So this is path number 1. There's still other path available, such as 1, 2, 3, then 4, 5. After that, 10, and then go back to 1. After that, 11. Okay, any path that available cannot be the same path, a different path. At least one new set of a statement or new condition. So this measurement used to measure, this metric used to measure the complexity attributes. Relationship between internal and external software quality. Okay, here, example, 4 quality attributes. Okay, maintainability used to measure depth of inheritance tree. Example, cyclometric complexity, the size, in line of code, the length, reliability, and the other attributes that used to be measured. So this one, you may refer software engineering book, the which one? I think last sem, Ian Somerville. Process metric. Okay, before I proceed, this one for the internal attribute, most of the time, this measurement, they are not too straightforward. They need additional tools help in the measurement, this part. Yeah, when we use external, internal attribute, this area. Process metric measure different characteristic of software development. Keyword is here. Some of the process metrics are also metrics for the project and products. But in our case, we don't have to, I mean, in our project, our assignment, we don't have to be specifically mention either process or project or product. Yeah? We just need to find out one attribute, one metric, how to measure. That's it. So example, measures of errors uncovered. What else? Before release, defect. So measure errors. So all these are keywords. You can take it as reference, what you want to measure in your project. So errors, you can defects. How much work done? Okay, this one on productivity. Schedule conformance, I think not so relevant. Human effort. So all these attributes, how do you know which one is the best fit? You have to look at what is your company goal and objective. If one of the objective is talking about the availability, then you might find relevant metrics to use to measure availability. Don't look for others like productivity or efficiencies. Time. Okay, if you want to measure how many person in hour in order to complete the desired or expected work, then you have to use this. What else? Oh, same effort, time, error. So all those are keywords, you take it as reference. Types of process metric. Time, resources, numbers of occurrence. So the time taken for a particular process to be completed, it can be, okay, I think this slide very good. I give you a lot of example. You can use to measure total time devoted to the process, and then what is the time spent in particular process. Resources here, you might use effort per person day metric, travel cost, computer resources, numbers of occurrence, let's say defects. Yeah, you are measuring how many defects in a time frame, in a specific time frame. After that, number of bugs. What else? Average number modified in response to required changes. So these two are the most common. Private and public. This one, please highlight. This is popular question. Popular question in the assessment. I think tutorial also we do have this. Yeah, public, private. What is a private metric here? Private to individual and serve as an indicator for individuals only. So this measures takes for an individual software process. These are usually private, private for individuals or not only individual but for particular team, used to improve individual performance or individuals or personal software process. And this one, private metrics. Example here, highlight these three. So these three, example number one, defect rates for an individual. Defect rate by modules. Error found during development, okay, sorry. Error found, you can test it up by KLOC or LOC. How about public metrics? So just now, private is on individual. Public here, integrated information that was originally private to individual and teams. Example, look at the overall project level defect rate. So these public metrics used to improve the organization process maturity. Just now, the private metric is on individual. This public metric used to improve the organization, overall organization process. Here, defect effort related data. Another one here, can write it down. So this also can be used, defects, defects. You jot it down. So in a project level, defect rates, effort and the related data has to be collected. So same goes to our project. We have to collect relevant data, then only we test it out. So all this used to help to improve the organization process performance. Sorry, stated here. Personal software process uses private process metric designed to help software engineer improve their performance. So how they improve here listed very clearly. This slide is clear. So each level has a detailed script, checklist, and template guide the engineer through required step, help them improve personal software process. So this personal software process, or in short, I just call it PSP. So this the engineer should plan the project before developing, because without planning, without spending the effort in planning, later on they might, if without a good planning, there are a lot of important activity could be missed out, where might lead to the final result become very poor or unsatisfied results. Again, if we didn't do according to our planning, if we didn't measure towards the end of the project, when we measure the outcome, if any changes, it might cost a lot of money. Not only cost, but also time. You need a lot of time to redo some of the component. So core measure size, effort, quality, and also schedule. So software developer use many other measure derived from the basic measure. So this one we cover in the previous topics. Next one, we look at the project metric used by project management to check the project progress. So by comparing actual metric with the expected metric, purposes to minimize development schedule, making necessary adjustment. Next one, what else? Improve quality. Yeah, so in our project, if you can find out what is, not say find out, if you can state it out what is your expected metric, and then from your test range, the result, whether the result from your testing fulfill, memenuhi what you are expecting or not, and then you draw a conclusion. Collection. During estimation, metric collected from past project, if we do have past project. Okay, collection of project metric. During estimation, we will use the metric from past project as a basis from which effort and time estimate are made for current work. So during project execution, schedule, what we are schedule, and the actual milestone dates. This used to monitor the progress of our process. So during technical work, you can check out number of errors. How about the effort? Pages of documentation, is it enough? Function point, this is one topic. We will learn function point. And then source line per task. So these are the measurements, example of measurement or metric. So if you can find out, if you can, from your research, you're able to find out relevant metrics based on the past project, which is very similar to your system, then you take it as your reference. Software measurement. Any questions so far?
No.
No question. Okay. 4.3. Function point, direct and indirect measurements. So direct, indirect, as a name, direct, so mean more easier to correct, to collect, more quantitative. So this direct measures does not depend on any other attributes. Okay, does not depend on any other attributes. Examples here, line of codes, execution speed, memory size, defect over time, and let me write down one more. So let's say if we would like to test out reliability, direct metrics for reliability we can use. So this one stands for mean time to failure. If you're interested on doing this, you might go and find out what is this matrix and how this metric can be used to measure these attributes. Right, jot it down. This one, quite not say popular, just like the KLOC is a classic metric. Same goes to mean time to failure. Indirect measurements. Look at the explanation here. Quite difficult to measure. Oops. Quite difficult to measure. How to measure quality? Yeah, quality is something that we need if we look at execution speed, this is quantitative. Numeric value, we can represent it with a numeric value, but quality, how? Not so easy to collect relevant data used to measure these features, right? Other than that, like efficiency, reliability, maintainability, complexity, all these are indirect measures towards non-functional requirement. Yeah, but still can express in quantitative form. That's why we need to find out, okay, based on this explanation, still can be expressed in quantitative form. That's why from there we need to find out relevant metric to measure this. Even is tougher compared to direct measure, but we still manage to find some relevant metrics. Is that the one and only, I did mention just now, is that any list, Miss? I'm sure some of you may going to ask me, Miss, how this one, which metric, how do we know which metric is which one? Yeah, as I mentioned, there are no specifically assign one metric for one particular attribute because the attribute definition we know, but how's the degree of this quality depends on the scale, the range, everything depends on your individual's software environment. Yeah, the scale for yours, the scale that using by your organization might not be, the environment might not be same to others organizations. So what you need to do literature review, do a lot of research, find out which is the best match. Normalized metric, this is a good example. You see, project A has 20 errors. Project A, 20 errors. Project B, 50 errors. Can we conclude that project A with better quality? What do you think? What do you think? Can we conclude that project A with better quality? Look at numbers of errors. Okay, type your answer in the chat box. Everybody, give me your answer in the chat box. Everyone, yes, 15 of you. Project A, from your answer, from our discussion, then let me see whether do you, what's your opinion on this? Project A, 20 errors. Project B, 50 errors. So all of you say no. Why? But look at the number, very straightforward, right? 20 less than 50, then we know project A, better quality lah, because less error. Then your answer is no. Why? Why no? Why not? Why don't? Why can't we conclude that project A with better quality? Give me your answer, chat box. So both are different project with possible different complexity tasks. Well done. Some more, I need more students contribute, not only 1, 2 students. If possible, everybody show your answer opinion. Yeah, give me your answer here. We are testing out whether do you understand so far. Some more, some other answer depends how big the project, not specific enough. Wow, very good, huh? Some more other answer. Maybe some of you still typing. I give you 1 minute. Okay, I get back 1 minute. Other student, I think not up to half, not up to 50% answering this question. Yeah, early morning. Think of it. Why can't we make a conclusion? Project A has better quality with the number of errors lesser than project B. Good answer, Elwin. Elwin's always provides some, what is it? Creative, out of the box, think out of the box answer. Very good, well done. Yeah, other students also well done. Some more, only 1, 2, 3, 4 students out of 15. Where's the rest? Russell, Noel, Farrell, different resources. Yes, good. Wong, Solomon, Ivan, Celine, Shark. Everybody, give me some keyword. Switch your brand a little bit. Why? Why and why? Why not? Yeah, we cannot just accept. You have to think of it. Why cannot? Yeah, we don't just accept other people's opinion. You have your own opinion. Why cannot be? Both with different project and possible different complexity and tasks. Yes, because we don't know the size of all the complexity of the project. So we cannot compare like project A lesser error and then project A with quality. We have no idea what is size and complexity of the project. That's why we cannot answer that questions. Yes. Yeah, how big or how complicated, complexity of the project. And then, yes, not specific enough. They just give me a figure. Cost and resources. Yes, they are they also depends on resources available. Maybe project A, they have a better resources, expertise, professionals, was that expertise, professionals, human resource, workforce. What else? 20 problem might be serious. Yeah, more complicated, complexity also. Different resources, yes, correct. Different test metric for both project, yes. Yeah, perhaps they are using different. Oh no, if they are searching for error, mean should be using the same. They will use error per 1,000 lines of code or line of codes. Different numbers of input and output, yes. Both might have different level complexity. So assuming 30 error is more better than 50 error is not accurate. Okay, different level complexity, correct. Different outcome. All right, good. Well done, everyone. Yes, so we can't answer these questions unless everything are being equal. But how do we know the equality is we even though you're using the same resources, but state on that stage they are full with uncertainties. Yeah, the expertise could have, let's say, sick problem performance. Yeah, not feeling good, not healthy, then their performance could be lower than compared to other project, even though they're using the same resources. There cannot be everything be equal. However, if the measure be normalized, okay, however, if the measurements are normalized, so that will be possible, yeah, to correct software metrics that enable comparison to the broader organization average. So these normalizations of metrics between projects are required to reduce or get a value which is comparable fairly between different projects. Initially, we can't really answer this question due to there are a lot of uncertainties, different complexity. But after normalize a project, yeah, we make it as fair as possible, fair manner between projects. So we can compare now. So two methods here to obtain normalized metric to compare different projects. We use size-oriented and also function-oriented. So this one, please take note. Yeah? Okay, size-oriented and also function-oriented. Okay, up to here, any question? So later on, we will look at what is this size-oriented and also functions. So let's take a short break, 1 hour. 29, okay, we are doing good. So let's take a short break. We come back later. Continue normalize metric after 15 minutes. See you. Let's come back to the class. Everyone here? Raise hand if you are here. Lim joined us already. Lim absent today. Lim is here. So no one absent today. All right. Please set your alarm, Lim. 2 times, 2 times, 2 times, 3 times. Let's continue. Normalized metric, size-oriented metrics. So what is this? Oh, sorry, my cable. So this one, size-oriented software metric derived from normalizing quality. Normalizing quality here. Or productivity by considering the size of the software that has been produced. So let's say, for example, quality. Example given here, quality we measure by errors per 1,000 lines of code. Productivity we measure by line of codes per person month. So this person month is used to measure how many people might be needed to finish a work in a fixed time. We look at this table. There are 3 projects here, alpha, beta, gamma. If a software organization maintain a simple record, so simple size-oriented measures can be created something like this. The table lists each software development project that has been completed over past few years and the corresponding measure for the project. So we look at the table entry here. For Alpha, Project Alpha, 12,100 lines of codes were developed with 24 person months of efforts, with the cost 168,000. Okay, we need to be noted that all the costs and efforts that recorded in the table here represent all software engineering activities, including analysis, design, coding, and testing. Yeah, not only focusing on coding, but also represent other activities such as analysis, design, and testing. So further information from here, PPDOC indicates 365 pages of documentation were developed. 134 errors were recorded before the software was released. 29 defects were encountered after release to the customer within the first year of the operations. So 3 people worked on the development of software for Project Alpha. So in order to develop a matrix that can be assimilated with similar metrics from other project. In this case, we choose LOC. So LOC lines of code has been chosen as a normalization value. Again, this one LOC metric is one of the earliest and simpler metrics used to calculate the size of the program. Any question up to here? If no, let's continue. These are example. This one important highlight. Okay, all these are examples of normalized size-oriented metrics, so you can use all these. Cost per line of cost. Anything new here? Cost per page of documentations. Common one, this one. One error per, this one. This one depends. Yeah, depends. Cost per pages. Comparing these two, so this one more common. Function-oriented metric. This functionality actually cannot measure directly. It must be derived. Yeah, it must be derived, mentioned here, using other direct measures. We call it function point. Okay, I repeat. This one functionality cannot be measured directly. So that's why we use indirect metric. We will derive this indirectly using other direct measures. What are the direct measures? Here. So in this case, function point or function area oriented metric suggested. So we look at what is this. More straightforward, look at the formula here. FP stands for function point. Count number, sum of all function point entry. Phi are complexity adjustment value between 1 to 14. So this value, this adjustment value based on the response of certain questions created by the organization, such as they might need to answer whether, example, does the system require reliable backup or recovery? They give a point there. They give a I value. There are a series of questions, not only up to one question. Other questions such as, is the performance critical? Is there any other way to upload the file online? Is there any internal processes complexity? Or whether the code design are reusable? There are a lot of, a list of questions that need to be responded. There are lists of questions that responds to this value. I think the question is listed here. Yeah, this one. Complexity adjustment value are obtained from the following questions. So this is how they get the I value. We'll come back to here. Look at the slides. So count total is a sum of count from the following measurement parameter. Number of user input can be the click. Yeah. Number of user outputs such as reports, error messages, numbers of user inquiries, helped, requests, number of files and external interfaces. Yeah, a lot of example given. So how to count? We look at here. Look at the screen here. So the function point are computed by something look like the table here, table shown in the slide. So 5 information domain characteristics are determined, and also the counts are provided in the table here, in these locations. So the information domain value defined in the following manner, including this part 1, 2, 3, 4, 5. These are the measurement parameter. Yeah, with example given here. After that, the organization might use a function point method to develop the criteria and determine whether the particular entry is a simple, is an average, or complex. Okay, in the slide, this part, this area, this, no worry, this is overlapping because all these are example come from here, this part. So you might list out lah. You might list out the example here into here. Okay, this one. They're repeating actually. Okay. Any question? No question?
No.
No question. So as mentioned, each complexity adjustment value come from the responses to the following questions. So each of the question is answers using the scales that range between 0 to 5. Yeah, each of the question that answer using the scale will range from 0 to 5. So 0 here means no influence, means not important or not applicable. 5 here, essentials or absolutely important or essentials. So within this scale, 0 to 5. Listed here. So we look at this exercise. So first of all, look at the parameter, look at the count, look at the weighting, and also the value 60. So what is this? What is this? You look at the formula here. Okay, sum of 5, the complexity adjustment value. So most of the time it has been given, yeah? This part. So count total. How to get the count total? Formula already given here. So function point. Count total 2 times 5. You will get 2 times 5. You will get 10, right? So what is the total? Okay, count for me. Here is 8, so you need to plus 28 plus 21 plus 16. What is the total? What is the count total here? Answer? $83, correct, Pharaoh. So that is 83. So the count total here, 83 times 65 plus, okay, sum of 5 here is 60. So 60. Answer. Okay, count, take out your calculator. 103.75. So here is 103.75. So function point is 103.75. So what's the purpose of this? So you come back to the definition here. Some of the functionality, no, not this one. A function point measure the functionality delivered by the software system as a normalized value. We need this because some of the value cannot be measured directly. So we need, in order to normalize those, we need function point. So this function point will need to combine with here. Yeah, you look at here. Example of functionality with the normalized value. So this is a function point that we calculated. Okay. Number of errors per function point. Okay, any question on this? Okay, the reason of a function point, because some of the function cannot be measured directly. Yeah, cannot be measured directly. That's why it needs to be derived indirectly using other direct measure. Okay, listed examples here. The direct measure, number of errors, but with the function point together. So this one can be measured directly, yeah, using this size-oriented metric, this one directly, up to normalize. For those functions that cannot be measured directly, we need to normalize it with function point. So examples, metrics used listed here. Exercise. You all try this. 5 minutes. I think question A should be no problem. So now, number B, they're talking about page of documentation. So you need, with this scenario, you need to decide which metric is suitable to be used based on this scenario. Okay, 5 minutes, we check the answer. Once you have done, write down the answer in the chat box. Other answers other than Noel's? That's a function point for project A and B, and question number B, documentations. Yeah, pages of documentations with function point. Same as Noel's. How about other student? Question B, Heaven, yeah? Okay, 5 more minutes to you. 5 more minutes to you. Oh, question B. I give you a hint. For question number B, 120 pages of documentation. So this is a keyword. For project A, and then 190 pages of document for project B. So they want to test. Now, this is the attributes that they want to they want to do. So same goes to our project. This is the quality attributes that they are looking for. Yeah, quality attributes. Now they need to find out a suitable matrix. So we are now doing function point with pages of document. So which function point? Document. So which one is the most relevant matrix used here? This one. Okay, this is the most relevant matrix, can be used to solve question number B. So apply this matrix. Pages document is a figure. Pages document, oops, 120 with a function point. Project B, pages of document 190 with a function point. So after you get the result, you compare the answer. So usually the highest result, number of pages or pages of documentations over the function point, the highest value it has, showing that because the more document they have, they are listed out the details, more details in their business processes, not business processes, the software processes, help in maintainability. So we compare the figure, which one higher. So 1, 4, 3. And then project B. So let's check the answer here. So project A with 83.75. Okay, all of you look at the chat box. The answer is correct. For project A, the function point is 83.75. Project B, function point is 153.75. So this is correct. So after that, now we are measuring maintainability attributes using function point. So 1, 4, project A, 143, correct, 1428. Project B, correct. Isn't it? Where is my calculator? Yes, yes. 236. So how to get the answer? So let me find out, let me list out here. So you have a project A. So now you have a project A. You have project B. So what's the metric we use? We use pages document over function point. So page of document, project A, we have a 120 over your function point. So somewhere around, if I make it to decimal, then will be 1.43. Project P 190 pages document over function point 153.75. So we get 1.24. So make a conclusion here when comparing to these two values. Project A has higher maintainability than project B. Okay. So make a conclusion there. Project A has higher maintainability than project B. Okay, the numbers of pages documentation, the higher it has. You see here, even though from here, project A with 125 pages of documentation, but after normalized with function pointer, is actually only 1 point. It has, even though the number of pages for project A lesser than project B. Do you see that? 120. Am I presenting? Yeah. 120 lesser than 190. Seems that project B more pages. But however, when we use, when we measure, when we use using the normalized metrics, we found that which one higher? It's actually project A with higher pointer, 1.43. We are measuring maintainability. So this is indirect attributes. In order to measure this, we need to derive the indirect measurement to become direct measurements using function points. Any question up to here? There are questions in a tutorial. Yeah? Tonight, everyone, please solve tutorial 4. No question. Straightforward. Yeah? This one easy to understand. Let's continue. We have about 10 more minutes here. So metric for software quality attributes. MECO software quality model. This is a old model introduced roughly about 1970 plus, 1977. So this model incorporated many attributes here. You look at here, they are about 5, 3, 3, 6, 11 attributes. Or attribute here also can refer to the factors which might influence a software. So they categorize it to product operation, 5 attributes or 5 factors, product revisions, 3 factors, and product transition, another 3 factors. Okay, take a look at the factors here. So product operations here used to fulfill specifications. Product revision here used to with the ability to change the software products. And product transitions here, the ability to adapt to the new environment. So for product operations, there are total here 5 factors. Correctness, integrity, reliability, usability, efficiencies. These are related to the requirement that directly affect the operation of the software. So this factor might help providing better user experience, let's say usability, with better user interface. Yeah, definitely might enhance the user experience. How about product revisions here? Here includes 3 software quality factors: maintainability, flexibility, and testability. What is this used for? So this product revision might provide the ease of maintenance, flexibility, and testing efforts to support the software to be functional according to the requirement. Product transitions here including 3 factors that will allow the software to adapt to the changes environment, to the new platform, or to the from the old technology to the new technology. So what metric can we use for software quality attribute? Correctness, maintainability, usability. So identify a correct testing metric is very important. There are few things that need to be decided before we identify the testing metrics. First of all, you need to know who is your target audience. So mean you are doing this test is for who? Jot it down. This is extra points for your reference. First, you need to know who is your target audience. Yeah, to who? You are doing this experiment, you are doing this testing is for who? Is it for who are the users? After that, you need to determine what is the goal, what is the purpose, what is the goal of your metrics. And then next, you might list down all sort of relevant metrics. Last one, you choose the best. Yeah, choose the most relevant metrics, which is according to your software system environment. In terms of correctness, the extent to which a software will meet the requirement specifications. So commonly, correctness will be measured using defects per KLOC. Okay, defects, if you search online, sometimes you will see they just write like this, this way. So defect, a standard period of year. How about maintainability here? Look at the explanation in the slides. This one, the efforts are required to detect and correct the error during the maintenance phase. So no direct way to measure, so must use indirect measure. So funny, so no direct way. So we use indirect measure. So the common metric, this one. MTTC, please do more reading on this. If you are planning to what is it? You are planning to measure these attributes. The time it takes to analyze a change, request, design, and appropriate modification, implement the change, test it, distribute the change to all users. You may search on this and then look at the formula. Yeah? Look at the formula. What are the components involved in this matrix or the formula? Usability. What is this usability here? Look at the slides. How easy it is to use a system. So can be measured using this. Okay, this is a top up. So from that, you develop from the questionnaire, the questions that you ask shall be related, and then you come out with the schedule, not schedule, table. List out the results. Challenges in a measuring software. A lot of challenges. Measurement is too complex, yes. Too complex due to different system environment. Too esoteric that very few professionals could understand. We are doing our best. We are slowly understand it. Yeah, there are too many metrics available with different environment. So we do our best to get the most relevant. What else? So many researchers attempted to develop a single metric that provide a comprehensive measure of software complexity. Derived metrics might not be useful or suitable. In other words, metric might not prove anything, take too much time. But it's everything, all these are depends on what is your test range. Too difficult to determine what to measure. Okay, I agree on this. Too difficult to determine what to measure and evaluating measure. So what to measure, this one, you please refer to your objective and also your goal. Okay, take note, this objective, we learn the SMART, right? Our objective need to be, has to be measurable. We are doing software project management. What we are doing now is we are assessing we need to assess the quality of the process. Yeah. We are focusing on this in our course, quality of the process. That's why we have to include measurable, measurable in our objective, because we need this to measure. We need this in our quality plan. That's why our objective have to include SMART. But in a real world, let's say you are develop an application. Let's say you're doing a project, You're doing a project, you develop a system. The objective for your application, you are develop something new, develop a new system, then your objective might not need to be too specific on this. Okay? Take note, this one only because we need to do quality plan in our course. That's why we a bit more particular, and not say particular, we more specific. We want this because we want to measure the quality of the process. But if let's say you are doing your final year project, you are develop an application, a new apps, you are doing something new, you don't have to apply this in your objective. Everybody clear? Everybody clear? Yeah, this one is for us, but in your final year project or real world, you might going to develop something new. You are not going to measure the detailed quality, like what you're doing quality plan here. That's why real world, your objective not necessarily has to be applied to this. Okay, next. Characteristic of a good metric must be consistent, independent, simple, and complicated. Don't look for so complicated formula in the matrix. Later, you also confuse how to measure. Easy to learn, easy to derive. Should be measured, do not lead to combinations of unit. Should be based on analysis model, design model structures. Okay, what else here? Okay, not too ambiguous, consistent, straightforward. Motivate team for software development improvement should lead to high quality end product. All right, that's all for our chapter number 4. We are on time, 1 minute. So next class, tomorrow, we will discuss tutorial 4, question 1, 2, 3, and 4. Only 4 questions. All of you, please solve the question. So we just need to discuss the answer. Yeah, we don't, or else whatever we discuss, you have no idea, but you haven't tried it out yet. Provide 2 normalized metric would be appropriate, justified. So there are no perfect answer here. Have to look at your justification. Which one is appropriate to the beam scoop project? Question 2 shall be no problem. We did exercise just now. Question 3 also. Normalize, also no problem. Question number 4, security. Concern on the security. And then 2 example of metrics. This one, please do research. Please do some reading online to find what is the relevant metrics available for security attributes. Any question? Any questions? So I prepared tutorial 4 document to you. Place your answer in. If no question, we will dismiss for today. Thank you, everyone. See you tomorrow.